Let's talk about how we can use the algebraic concept of factoring to calculate angle measures created by parallel lines and transversals. What we're going to be doing in this lesson is really the same thing as what we've done in the previous lessons. It's just that the solving part is going to be a little bit more complicated. So for example, in the diagram that you see on the screen, these two marked angles are still just corresponding, so I would set them equal to each other and solve. But the solving part is going to be a little bit more challenging because of the x squareds. So before we get started on dealing with the x squareds, let's make sure we remember what kind of pairs of angles we're looking for. Corresponding angles occupy the same position. When two lines intersect, four angles are created. And the angles that occupy the same position out of those four angles are called corresponding. So for example, angle 1 and angle 3 are both in the top left-hand corner out of the four angles that get created by each intersection of lines. That makes them corresponding, and if the lines are parallel, then the angles are congruent. We also learned about alternate interior angles. Alternate means that they're on opposite sides of the transversal, like how 2 is on the left-hand side and 7 is on the right. And interior means that it's in between the two parallel lines. So if the lines are parallel, then the alternate interior angles are congruent. And we learned alternate exterior angles, which are similar to alternate interior in that they're on opposite sides of the transversal. That's what alternate means. But instead of being in between the two parallel lines, they're on the outside of the two parallel lines. So for example, angle 1 and angle 8 would be congruent if line A is parallel to line B. And then of course we just had to have one that's different than all the others. Consecutive interior angles aren't congruent, they are supplementary. Consecutive means that they're on the same side of the transversal, like how angle 2 and 3 are both on the left side of transversal T. And again, interior means that they're in between the two parallel lines. So angle 2 and angle 3 would be supplementary if the lines are parallel. Okay, so that's our review of what kind of angles to look for. Let's review the concept of factoring from Algebra 1. You're going to have to factor in order to solve an equation like this because it has an x squared and an x and a constant. Anytime you see this ax squared plus bx plus c kind of form, you're going to have to factor. In order to factor, you need to find the factors of c, in this case 35, that add up to b, in this case 12. And when I say factors, I mean two numbers that multiply together to get to that number. So what can I multiply together to get to 35? Well, there's only two options. I can either multiply 1 and 35, or I can multiply 5 and 7. Either of these pairs of numbers multiply up to 35. But I need to pick the one that also adds up to 12, which would be 5 and 7, because 5 plus 7 is 12, and 5 times 7 is 35. That's the correct pair of factors for my answer. The factored form of equations that look like this will always come in this form. You'll have x plus something and another x plus something, both of those written in parentheses. And the blanks just get filled in with whatever your numbers were. So I'll put a 5 here and a 7 there. Or vice versa. You could put a 7 here first and a 5 there second. It doesn't matter which one's which, as long as you have them both. So that's our factored form, and now we need to solve. In order to solve, you're going to set each of the quantities separately equal to 0. So I'll say that x plus 5 equals 0 and solve, so I get x equals negative 5. And I'll set x plus 7 equal to 0 and solve, so I get an answer of negative 7. Alright, let's try another one. Same idea, we need to figure out the factors of c that add up to b. What do I multiply to get to 40 and add to get to negative 13? Well, there's a bunch of options for 40. There's 1 times 40, 2 times 20, 4 times 10, or 5 times 8. These are all pairs of numbers that I can multiply to get to 40. Now for some of us, figuring out these pairs of numbers is really easy. We can do it in our heads. And for some of us, it's like super hard. So if you're one of those people that struggles with finding factors of a number, just get out your calculator and take whatever number you're trying to find the factors of, in this case 40, and divide it by 1. And then write down whatever you get. And then divide it by 2, and write down whatever you get. And then divide it by 3. And you'll notice I didn't write down anything this time because 40 didn't divide by 3, so that's not a pair of numbers that I would want to write down. So I divide it by 1, divide it by 2, divide it by 3, then I would divide by 4 and write down whatever I get, and divide by 5 and write down whatever I get, And then I would divide by 6, but again that would give me a decimal, so I didn't write it down. And then I would divide by 7, but again that would give me a decimal, so I didn't write it down. And after 7 comes 8, but we already had 8. So this must be my complete list of factors. So now I have to look through this list and decide which of these can I make add up to a negative 13. Now keep in mind, you can put a negative wherever you need to on these numbers to make them work. So is there any way that I can put a negative on 1 and 40 to make it add up to negative 13? No. Or 2 and 20? No. 4 and 10? Close, but no. What about 5 and 8? Yeah, if I make both 5 and 8 negatives, then it adds up to negative 13. And that also makes sense for my positive 40 because a negative 5 times a negative 8 would give me a positive 40. So this would be my factored form, x minus 5 and x minus 8. Or flip-flop, you can write x minus 8 times x minus 5, the order doesn't matter. So to solve, I will set each of these equal to 0 individually and get an answer of positive 5 and positive 8. Let's try another one. I need to figure out the factors of negative 10 that add up to 3. Well, there's only 2 pairs of factors of 10, so that's pretty easy. I can only multiply 1 and 10 or 2 and 5. That's the only way to get to 10. So which of these can I make add up to 3? That would be 2 and 5. But I need one of them to be a negative and one of them to be a positive, right? Because if they're both positive, then it's 7. And if they're both negative, then it's negative 7. So which one do I need to put a negative on if I want to add it up to a positive 3? That would be a negative 2, right? Negative 2 plus 5 will give me positive 3. And that makes sense for my negative 10 to have one of these be a negative, because if I do negative 2 times positive 5, that gives me a negative 10. So I'm going to write my factored form like this. X minus 2 times x plus 5. Or flip-flop, x plus 5 times x minus 2, but the negative has to stay with the correct number. The negative goes on the 2 and the positive goes on the 5 because we're adding up to a positive 3. So to solve, I'll set each of these equal to 0, and I get an answer of a positive 2 and a negative 5. Alright, I want you to pause the video and try the last one on your own. Alright, let's see how you did. There are a lot of factors of 48. You've got 1 and 48, of course 1 and whatever number is always the easiest pair of factors to find, but we also have 2 and 24, and 3 and 16, and 4 and 12, and 6 and 8. So you have to figure out which one adds up to negative 8. And that would be 4 and 12, but only if I make the 12 negative. Because if I'm trying to add up to a negative 8, I would need to do 4 plus negative 12, or 4 minus 12. So my factored form looks like this, x minus 12 times x plus 4. Or flip-flop the order, you can say x plus 4 first and x minus 12 second, but the negative has to go where it's supposed to with the 12, and the positive has to go where it's supposed to with the 4. So to solve, I'll set each of those equal to 0, and I get answers of 12 and negative 4. Okay, so let's put it all together. We're going to combine the special kinds of pairs of angles that are created by 2 parallel lines and a transversal with factoring. So the first thing I need to do is identify what kind of pair of angles I have. In this case, they're alternate interior, because they're on opposite sides of the transversal, one's on the left, one's on the right, and they're in between the 2 parallel lines. So since they're alternate interior angles created by 2 parallel lines cut by a transversal, I know that these 2 quantities have to be equal to each other, because alternate interior angles are congruent. So the equation that I'll write is this, x squared plus 6x equals 3x plus 54. So I just set these 2 things equal. In order to solve, I need to get this to be equal to 0. In other words, I need all of the information on one side of the equal sign, and nothing else on the other. So I'm going to subtract 3x, and I'm going to subtract 54 from both sides. If I subtract 3x from 6x, I get 3x. If I subtract 54, well, there was no other constants over here on the left-hand side. There's no like terms to combine it with, so I just write minus 54. And the x squared stayed the same because there was no other x squareds to combine it with. So now I have all of the terms of this equation all on one side of the equal sign, and the other side is equal to 0. So now I'm ready to factor. What are the factors of negative 54 that add up to a positive 3? If you said 6 and 9, you are correct. The 6 is the one that needs to be a negative, and the 9 needs to be a positive. That way it adds up to a positive 3. So I'm going to set both of these equal to 0 and get my answers of 6 and negative 9. So my answers are x equals 6 and x equals negative 9 by the alternate interior angles theorem. Now you might be saying, well, wait a second, how did we get a negative answer for x? That can't possibly be correct. I can't have negative angle measures. But it is actually one of our possible solutions, because if you plug it in, for example, if you plug it in here, 3 times negative 9 plus 54, that ends up being 27 degrees. And you get 27 degrees when you plug it in here as well. And if you plug in 6, you get an answer of 72 for both of those angles. So when you're solving problems that involve factoring, you're actually going to get 2 potential solutions because of the way that factoring gives you 2 different answers. You should always double check and make sure that those answers make sense. Make sure that they're not a negative angle measure, or make sure that they're not more than 180 degrees, because that wouldn't make sense either. But most of the time you'll end up with 2 answers. Let's look at another one. This time, what kind of pair of angles do we have? They are corresponding. They're both in the top right-hand corner out of the 4 angles that get created by the intersection of the lines. So these are both corresponding angles, and we know that corresponding angles are congruent. So to write this as an equation, I will set these 2 quantities equal to each other. My goal again is to get all of the information on one side of the equal sign. And it might be tempting to move these 2 quantities over to the right because it's less stuff to move. But you actually have to have your x squared term be a positive number in order for factoring to work. You can't work with a negative x squared. So I'm going to move these 3 terms all over to the left-hand side. That way I end up with a 1x squared, a positive x squared, for my first term. So let's subtract 2x squared, and subtract 2x, and subtract 45. And I would end up with x squared plus 12x minus 45 equals 0. So since I have all of my terms on one side of the equation and the other side is 0, I'm ready to factor. What are the factors of negative 45 that add up to 12? The answer would be 3 and 15. If I wanted to add up to a positive 12, the 15 needs to be positive and the 3 will need to be negative. So next I will set each of those equal to 0 and solve. So I get answers of x equals 3 and x equals negative 15. You should always double check your answers and make sure that they actually work. So for example, if I plug in 3 times 3 squared plus 14 times 3 gives me an angle measure of 69, which is between 0 and 180, so that's a good answer. But let's plug in negative 15. If you plug in negative 15 to either of these expressions, you get an answer of 465 degrees, which doesn't seem like a very logical solution, right? Because all of our angle measurements should have been between 0 and 180 degrees. So negative 15 for this problem actually doesn't work. The only answer, or the only logical answer that I get from this is that x must be equal to 3. What kind of pair of angles do we have on our next diagram? Well, they're both on the right-hand side of the transversal, and they're in between the 2 parallel lines, so that makes them consecutive interior. And we know that consecutive interior angles are supplementary. So I don't want to set these 2 quantities equal to each other. I want to add them together and set it equal to 180, which would look like this. So now my goal is to get all of the information, all of my terms, all together on one side of the equal sign. So I'm going to first combine these 2 like terms. 15x plus 1x is 16x, but I'm also going to subtract 180 from both sides. So my new equation would look like this: x squared plus 16x minus 80. And since it's equal to 0, I'm ready to factor. What are the factors of negative 80 that add up to 16? That would be 4 and 20, but only if the 4 is negative, because negative 4 plus 20 equals positive 16, and also negative 4 times 20 equals negative 80. So now I'll set each of these equal to 0 and solve, so I get answers of x equals 4 and x equals negative 20. It's pretty easy to double check your answers on this one because of this little quantity right here. Is 4 plus 100 going to be a valid answer? Yep, sure is. 104 is good to go. It's between 0 and 180. And if I plug in negative 20, does that work as well? Well, yeah, negative 20 plus 100 is 80. So that's also a valid answer. So we get 2 answers, all based on the consecutive interior angles theorem. All right, I want you to pause the video and try this last one on your own. All right, let's see how you did. These two labeled angles are alternate exterior angles because they're on opposite sides of the transversal and they're on the outside of the two parallel lines. Since they're alternate exterior angles, they must be congruent to each other, which means I can set their quantities equal. So I wrote x squared plus 4x plus 63 equals 2x squared plus 6x. You might have written it the other way. You might have written 2x squared plus 6x equals x squared plus 4x plus 63, and it doesn't matter. As long as you're setting those two expressions equal to each other and solving, you're good to go. So our next goal is to get all of the information together on one side of the equation. Remember that you want to keep your x squared term positive, so for me, the way that I wrote this, I need to move everything over to the right. So I'm going to subtract x squared and subtract 4x and subtract 63 over to the other side of the equation. So that means that on the left I'll just have 0 because I subtracted everything away. And then if I do 2x squared minus x squared, that's 1x squared. And 6x minus 4x is 2x. And then just subtract 63 from 0 if you want to think about it like that, and you get minus 63. So what are the factors of negative 63 that add up to 2? That would be 7 and 9. And 7 is the one that should be a negative number if you wanted to add up to a positive 2. So I set both of those equal to 0, and I get answers of x equals 7 and x equals negative 9. Do a quick double check to plug your numbers in and see if they make sense. If I plug in 7, I get 140 degrees. And if I plug in negative 9, I get an answer of 108 degrees. So both of those values of x give me valid answers for my diagram. So I would say that my answers are x equals 7 and x equals negative 9 based on the alternate exterior angles theorem. And that's all you need to know about incorporating the algebraic concept of factoring into calculating angle measures created by parallel lines and transversals. We'll be seeing more factoring as we progress through the year with triangles and quadrilaterals and more.